Here it is, fermentation chamber of doom. Now this is in the early stages, but I wanted to do a quick video of an overview of what's what and how it works. So this is an old cabinet that Elder P reclaimed from work. It was basically like a closet for hanging coats and stuff. We took the bar out, and then I built shelves to split it into 4 different chambers, and then we insulated it all with 1-inch pretty high R-value foam insulation, and that's the silver stuff. I think it's not a real high value, 6.5 what it says there, but it allows us to do 4 chambers, and this stuff does insulate very, very well. And I like the foil backing on it, so that's why I chose to go with that one. So we have 4 chambers. Each chamber can hold 3 5-gallon carboys easily, and 4 corny kegs. So it's kind of nice. You can do bulk aging and things, and lagering, stuff like that. Over here is the business side, and we're still in the early testing phases, but I'll give you a breakdown what it is, or what it consists of. Power in here, power out here. This goes to the refrigerator. Back there we have a circuit breaker for the system. It's 15 amp, and then power comes in, gets distributed down here for line voltage 115, 120 volt, whatever you want to call it. Back here we have an old computer power supply that's stripped down to only run the 12 volt output. That's 12 volt DC, comes into these guys here, and then we also have a 24 volt power supply here to power the PLC, this bank of RTD amplifiers, which take an RTD signal in, measures the resistance, puts out a 0 to 10 volt scaled output for, depending on what I have selected, but it's these sensors are set up for 0 to 100 Celsius, so that's what I'm running right now. Everything's in Celsius. That's okay. This guy's the analog input module. There's the brains, and then we have fuse for the fridge, relay to turn the fridge on, and a fan. It's got a 12 volt fan that blows the air basically out of the fridge and then back into the first chamber, and then a relay for the top left chamber, relay for the top right chamber, and a relay for the top bottom right chamber. So how it works is it's got to be set up so if we can get back far enough so I can show you guys. Okay, so the bottom left chamber is always the coldest, so it would be set up normally if we're not fermenting in that chamber or lagering. It would be set up for just like a fridge usage. Second coldest would be the top left, and then these 2 guys can be whatever temperature we want, generally lager or ale temperatures, ale fermentation temperatures. So down here right now, for example, I've got this one set to 18, and up here I've got this one set to 18 just to basically have some kind of set point. We only have 1 fermenter in right now, but it's doing the Dropkick Nate 10 gallons, and it's been holding rock steady at 18 degrees Celsius. So fridge only kicks on when it's needed. Right now we got this chamber set to 9 degrees Celsius, and this one's set to I think 14, and then these 2 are at 18. And the relays kick on periodically, but basically only when they need to. And the user interface is all done through this tiny little box here, and let's see if it'll focus. Probably not. Come on. So we got 4 different chambers, and right now we can see the temperatures of those chambers. So chamber 1 is running at 11, chamber 2 is at 14, chamber 3 is at 16, chamber 4 is at 16. So chamber 3 and 4 won't be asking for any cooling. And how that works is, so we got our main cooling source, and then we just have 12 volt fans to move the air from chamber to chamber, depending on what kind of cooling is needed. And the logic is pretty dumb on this. I would like to upgrade it someday. The logic is, if the temperature is over turn the fan on or turn the fridge on. Once it is under that temperature or at that temperature, it shuts off. And then there's a 2-minute kind of standby or delay so that the thing doesn't toggle back and forth if it's rocking between a rounding temperature between two set points, or a set point and what it's actually reading, if that makes sense. So let's say if it's 19 and I'm asking for 18, it turns the fan on, blows the cool air from down below until it reaches 18. And then if it's 18.4, it shuts off. If it's 18.5, it wants to turn on. So there's the little bit of error, since we don't have the finer resolution on the displays and in the logic. So this will probably be seeing an upgrade, probably to a software controlled system. I want to put something with some data acquisition, data logging on it. So that's it, and keep you posted with the updates. This front is going to get a panel, and then we're going to mount this into the panel so that it's a little easier to access and work with, and it's a little cleaner, so all the stuff is hidden, because it's not the tidiest wiring job, but I am going to clean it up a little bit here and there when time permits. Right now it's running, and that's the biggest hurdle, was just getting it going. Took forever, but it's rocking. And this cabinet's big enough, I'd like to put a touch panel right here so that we can have, a logging screen and show graphs and things of temperatures and how it's maintaining and how well it's doing. And if I had a little bit better logic and resolution on the temperatures, it'd be a lot better. So that's it. Hope you enjoyed it. Cheers.